This is a presentation about galaxy distribution. On the screen share, you'll see a graph which describes the count of galaxies by distance. Now, this graph was created from data from the NASA extragalactic database. And you can see on the bottom here, we have a redshift scale. So, for example, the redshift here is 0.002. The actual individual points are in divisions of 1/10 of that. So there are 10 graph points between each of these divisions. And so that's 0.0002 in redshift, which corresponds to about 2.75 million light years. So this axis is the number of galaxies in each distance band. So you can think of these distance bands as spherical shells with an increasing radius corresponding to this distance. And each shell has a width of 2.75 light years. So the form of this graph, and I'll show you in a little while how the data was obtained, is interesting because it seems to follow a curved shape, and superimposed on that curve is a kind of sawtooth pattern. And when I first saw this, more than 10 years ago, I was surprised because the count of galaxies isn't at all what you would expect from the Big Bang theory, which suggests that all galaxies formed from a widely dispersed cloud of gas and dust. I would have expected the data points to be much more random and a lot more statistical variation, so that you had points increasing, decreasing by 50%, but that's not what we find. So this this graph is one of the first things that alerted to me that the Big Bang theory was suspect. So I'm now going to share with you the data that this was created from. So this is a text file. Just bring these across into position. Hope you can all see that text file. So this is an access from the NASA extragalactic database, and it's from redshift 0 to effectively 0.005. And it was accessed in the year 2008 on the 25th of January. And you can see there's one row in the data corresponding to each galaxy. And what you get is longitude and latitude. So this is, longitude is a number which goes from 0 to 360, and latitude is a number which goes from -90 to +90. And so those 2 points give an angular direction towards each galaxy. And then I've used the redshift in this column, which effectively gives the distance. Now this this access is this file actually contains several accesses. You'll find that there's several files been joined together to create the full range of data that I needed. So you can see this is the next access of the galactic database, going up from 0.005 to very nearly 0.01. So that's the source of data. And having created the graph from this data, I also thought it would be interesting to look at the evolution of galaxy positions. So what I did was, for each distance band, I created a plot of galaxy positions using the longitude and latitude. And that then gives you a GIF file, a JPEG file, which gives a single frame. And by placing all these frames in sequence, you get a video which shows the evolution of galaxy positions. So I'm going to stop sharing for a minute and pick up that video. Get over to the center of the screen. So this is actually what you're looking at is the initial starting point, and I'm just going to press play so that you can see it run through. And what you notice is that the evolution patterns of galaxies seems to be, it's not like random noise. Each frame seems to be some kind of progression from the previous frame. And this suggests that galaxy formation is not a random process from the condensation of galaxies out of a cloud, but it's rather a process in which galaxies are positioned by some kind of process. It looks like I didn't put that video up, so I'm just going to go back into that. Apologies for that. Here's the video. Let's screen share that. That's better. So let me run through that again. So here's the video. I'm going to move it back to the first frame and just play it through. You can see the evolving pattern that I was talking about. Let's run that back again. These are the position plots taken directly from the text file data that I showed to you. So let's just run it through again. Okay, so let's stop that. Right, so what I'm going to do now is pick up the next file that I want to show you, which is desktop is getting a little bit cluttered, so I'll need to move things around to find the file that I'm looking for. Okay, so here we go. This is a slide taken from a previous presentation where it shows the evolution of galaxy formation. So here's the first galaxy forming, and within 14 billion years we have 20 galaxies, and every 14 billion years the number of galaxies increases by a factor of 20. So here we see 400 galaxies, but the point is that in 14 billion years the universe is expanding by a factor of E, which is around 2.7. So these aren't to scale. These galaxies would expand by a factor of 2.7, and then the next batch of galaxies would form outside of that existing region. So the formation of galaxies progresses, starting at a point closest to the center of the universe and progresses outwards, which explains the form of that graph. Just going to go on to the next slide and relate to the fact that this is again a slide taken from one of my other presentations, which shows our position in a finite universe. So this marks the center of the universe, which is a center with reference to the boundary of the finite universe. And the Milky Way is represented here, again, not to scale, but we know that the velocity of the Milky Way is around 552 kilometers per second relative to the cosmic microwave background rest frame. So we can use Hubble's law to work out that the Milky Way is around 26 million light years from the center of the universe. And also from this direction of this velocity, we can work out the position of the center of the universe relative to the Milky Way galaxy. So then it occurred to me that it might be useful to look at galaxy positions from the perspective or from the frame of reference of the center of the universe. So what I did was I took the positions of the relevant galaxies, and remember we had latitude and longitude and distance. Well, you can convert that into Cartesian coordinates so that you've got X, Y, and Z for each galaxy. And you can also plot the position of the center of the universe in Cartesian coordinates. So you get an X, Y, and Z value for the center of the universe with reference to the Milky Way. And from this, it's quite straightforward to plot the positions of the galaxies closest to the center of the universe. And that's what I did. So if we now do a screen share and pick up this one. This is a chart taken from the paper on the evolution of the universe, which is on the academia website. And what this shows is the view of the galaxies within 20 million light years of the center of the universe. So this point here is the center of the universe. And you can then identify this galaxy here as the closest galaxy to the center. So this is the first galaxy to form. And this is at around 9 million light years from the center. I should emphasize that this plot here is not a straight projection from some direction of the galaxy positions in X, Y, Z. What it is the vertical is the Z-axis, and the horizontal is a radius, which is the square root of x squared plus y squared. And I chose to show the minus values of y on the left and the positive values of y on the right. But by using r as the axis, it reveals a spherical region of empty space around the center of the universe. And so what we can see from this first galaxy here at 9 million light years is that we estimate that the first galaxy formed around 126 million years ago, which is 9 lots of 14 billion years. So 126 billion years and 9 lots of 14 billion years. But what that means is that in the time since this galaxy formed, the expansion of space has been e to the power 9, which is around 8,000. So it tells us that this galaxy formed at an approximate distance of around 1,000 light years from the center of the universe. And all subsequent galaxies that formed are further out from that point. So that explains the fact of this void located at the center of the universe. Now, obviously there are other voids in galaxy distribution patterns, but this void has been located by locating first the center of the universe and then looking at the galaxy plots around it. So there's one more thing that I want to show you related to this, and that's the plot of numbers of galaxies starting from the center of the universe. So here is the center of the universe, and here's the first galaxy at 9 million light years, and then there's nothing there's nothing here, and then 1, 2, 3, 5, 18. So if we count up the number of galaxies, we can reckon that with our idea that there are 20 galaxies formed within the first 14 billion years, that these galaxies here from 9 to 14 and a half light years were the galaxies which formed within the first 14 billion years. Now it's interesting to note the form of this curve as it goes beyond. It reaches a peak here and then drops down before starting to rise again. And my explanation for this is that galaxy formation forms from the expansion of space, and the tension builds up in the fabric of space-time until that energy is released in a galaxy formation event. And so these galaxy formation events have had the effect of reducing the tension in the fabric of space-time, which takes a certain recovery period before it picks up again. And so this is the beginning of the sawtooth pattern that we saw in the first slide. So that concludes the presentation. It does show, for me, that the galaxy distribution patterns seem to fit in reasonably well with the model of galaxy formation that I've presented elsewhere. And it does seem to suggest that the idea of the Big Bang theory, that galaxies formed from a very dispersed cloud of gas and dust, cannot be true.